I'd like to introduce Dr. Nagahanumaiah, the Director of Central Manufacturing Technology Institute. He's an experienced research scientist and accomplished operations executive. He has been instrumental in reshaping CMTI's mission as a technology developer, bringing 3 decades of professional expertise in the manufacturing sector. He has pioneered Micro-Nano Systems Engineering at CSIR-CMERI and holds 9 patents and has published 108 research articles. Today, he will share his insights on transformative powers of 4Ps in productive innovation. So please welcome.
Yeah, good afternoon. Thanks for having me here. As she already mentioned, I'm basically a researcher, so I'll try to give my perspective, kind of concepts or the reasons, the challenges in adopting the advanced technologies. That challenges I like more of categorized into 4 categories like product, process, people, and production. Um, I will give you from the technology perspective. If you look at the status of Indian innovation in industries, this is where the survey conducted by the government missionary. More than 56 to 60% of our innovation is new to company, and 9% is new to India, and less than 3% is new to world. So if we that clearly says what went wrong is product innovation or technology innovation is a challenge for Indians. If answer is yes, of course this is a debatable. If his answer is yes, there are few reasons to do. One is we always looked at science and engineering as a parallel pillars, but if you are practicing engineer or you are professional engineering professional, you must have realized uh, any innovations happened without engineering, it ends with the paper or the report. Or if any engineering without science is ends as a jugaad innovation, maybe it is difficult to repeat and reproduce and scale it. This is because our education system is percentage fake focused and all. I will not go all these things, irrespective of whatever the reason we do. The idea is to have technology. The drivers are always uh, basically whether you can able to do it yourself. Definitely that will add you, that will make you skillful, and you will become more free and independent individual. Then you are well prepared, you can always more confident in, particularly they say for example COVID must have taught us many challenges when we were looking at dependency entirely on some other countries. And then again, this also taught us that now cost of ownership of technology or cost of ownership of product becomes major driver for the technology. But unfortunately, technology development is a cycle. You need one has to go through the distinguished stages like research stage, technology, then training, then adoption. In each stage, we need basically we are addressing the challenges with respect to 4Ps. That is uh, with respect to product design, with respect to process design, I call it as a people design, and then the production. Each domain, each phase of technology development, a different set of challenges with respect to 4Ps one has to decide. Normally, it doesn't happen unless you collaborate and cooperate. Uh, at the same time, this also required, at least for Indian sense, we need to focus on made in India or originated in India. Anyway, made for India is now no longer exist. At least that is what we believe. But make in India is a process to reach made in India and then, if not originated in India. So I just look at one example here. This is I took a food area as a one focus domain where everyone can easily correlate. If you look at the technologies in a food research, the driving forces are healthy and nutrition products and better efficiency in food production. environmental and political impacts, reality and perception gap. So it is same or similar drivers are there in different domain, irrespective of whether you make a product or you make a production equipments or you make a process developers. The idea is there is a drivers, and second is there are also objectives. Objectives, say for example, in case of food research, reducing waste is your objective, better control of an equipment, enhancing customer experience, improving flexibility, accurate and food safety. And all these aspects are to be considered when you look at the technology which is innovated, which is developed, and then scale up to adopt industrial practice. But at the same time, if you given any time, so there are few technologies which are already in practice, either at your place or at your competitor's place. That is what I mentioned in black color. But there are always avenue and an opportunity uh, to do something which is of innovative. That is like, say, for example, if you're reducing a waste, predicting actions for producers and customers, like can you integrate IoT-based solutions? So like that, there are similar opportunity areas. You can one ask. What I mean to say is there are drivers, there are objectives, but don't need to kind of feel inferior or superior because every objective there is a technology interventions, and there are few technologies that are being already in practice or being implemented at your place or at different place, but there is always room for everyone. I think that is what is the message I wanted to give. So in order to do this, one has to look at multiple viewpoints. That means that four P's, what I want to say, and also look at cooperation and collaboration because we alone cannot do anything. And the irrespective of scale of operation, this now no longer R&D is research and development. It is now relevance and delivery. At least now we researchers very well understood this importance of R&D. So if you look at the challenges, 4P related challenges, so I just call it as a disc approach here. There is a product stage where major focus, your objective is, so basically we are trying to convert data into a design, and each, in order to do this, there are several technology. So maybe like mass customization, localization, or is a new product or novel product design, or frugal design. And then there are few other drivers like cost of ownership and when it should be implemented and introduced and why it should be and who, meant for whom. All those aspects has to be considered to convert the data. Data means what you wanted to do to a design, that is engineering design. If you look at a process, then innovation to inclusion. So starts with an innovation, people like R&D scientists. Then you need to include all the stakeholders. That is called, people call inclusive innovation. So there are different tools, different approaches to solve this. That is connect and commit, inquire and investigate, design and develop, implement and iterate. So if you come to the people, so basic idea is to collaborate and cooperate. So this also includes skilling. So usually the best choice is all in one. So that means you have all sorts of people in house. That will never happen. And then you need to teach, train, skill, mobilize, motivate, normalize, and much more than that. If you really wanted to promote cooperative and collaboration, I think we need to bring in the mindset. We need to create an ecosystem. So we work for, not for me, it is for us. I think there's always challenge collaboration and cooperation even within that organization. I think one has to look in very seriously when you look at the technology adoption in the manufacturing or in regular production. Then production in, so definitely this is a costly and expensive affair. So one has to look at scalability and the sustainability, and it largely depends on the capital, that is machines, automation, how do you harvest the knowledge, then ensuring productivity, improving quality, and then incorporating modularity and the flexibility. So in order to do this, just I call it as a disc approach. So if you really organization is derived both on the previous and the current practices in the industry or elsewhere. So then we can able to achieve our goal, and scalability of any technology irrespective of scale of operation, it becomes smooth. During this process, what actually we do, we only do on addressing these 4P challenges by using these 5 tools, that is 5 Fs. Either we deal with form, function, flows, physics, or physics need not be a physics. It is what I mean is science. Then the fabrication, that is on industry shop floor happens, is the production. This is why it is required is, so unfortunately in engineering it's always 1 plus 1 is always either 2 plus or 2 minus. It will never be a 2. So we need to use the technology. We need a technology to bring as nearer to 2. Will never happen 2, but definitely we want to reach towards 2. I think that is what the reality one has to look at when you look at the scalability of the technology. So this is another why it is so. There are 3 major segments when you look at the technology adoption or the innovation, adopting a new technology or the new product. That is, one is the design, another is a material, another is a technology. Each has its own domain, so it takes a lot of time. Say, for example, I'll just explain you prototyping. At the design stage, you cannot avoid the prototyping. But even when you look at a prototyping, there are different class of prototypes are required at different stages. One is like analytical versus physical prototypes, then comprehensive versus focused prototype. Each prototyping stage has its own influence, particularly when you look at the scalability of the technology after successful demonstration at the TRL level of, say, for example, 5 to 6. So unless you take care of this aspect at the prototyping stage, it's very difficult to adopt the technology in a higher TRL levels. And at the same time, say, for example, if you look at a technology, here I just listed additive manufacturing, AM. So there are so many challenges with respect to 4Ps. So one has to look into this. But yes, fortunately, there are tools. So, say, for example, I just listed a digital tool that would facilitate and speed up your prototyping process, or to reduce the prototyping process, the physical prototyping process. Of course, material has a major challenge, particularly in the Indian context. We have very limited resources for advanced materials. I think one has to focus on that. This is, and at the same time, the fundamentals matters. So I just listed kind of some small pictures. If you look at these pictures, the entire manufacturing process, what we know today, could be grouped into only 4 categories. I think this has to be appreciated when training a people. Fundamentals when you're training at the school or on absorption on the company on job training, one has to appreciate that fundamentals drives the innovation and fundamental drives the technology adoption. Because I don't see any manufacturing process which doesn't falls under this. So we manufacturing process, either we remove a material, shape a material, order the material, or assembly. That is what like chemistry, biology driven, biomanufacturing, self assembly, all those comes. So that means we need to skill people so that they appreciate the fundamentals. I think that is one of the major link which we now compromise a lot in the our education system. So once you can able to appreciate, then you need to look at material, then the processing, on operating at multiple scale. Multiple scale means the dimension scale as well as productivity scale. So then next is, there is a lot of rooms available when you look at a scaling up of technology into a production. So that is by adopting a novel approach, customization or hybridization. So this is one example I put across here, additive manufacturing, because you all know additive manufacturing is now the trend. People are looking at using AM for regular production if that is the objective. So this is a journey. You may be knowing the first patent of additive manufacturing happened 8th February 1987. The 3D systems for a stereolithography process. Since then, there were a lot of first, I think, 5 years, people were only looking at making prototyping. That time, people used to call rapid prototyping, and then to some extent using this to make some small early order requirements. It's like a not a functional prototype, but multiple prototypes. Then people started using this into art tooling. Then you can make a production parts or functional parts with same material, same process, and also the same um, conditions, so that are we can use and validate in the same real environment. But thereafter, so people looked at that it is how we can AM process could be used as a direct manufacturing, and now people are also looking at can we make a smart manufacturing so that additive manufacturing process can learn itself by integrating AI or ML based or generative based AI models, so that we can get a customized or kind of ready to use components. I think that is what a lot of research goes into this. But from the industry perspective, still challenges are with respect to geometry, tolerances levels, the materials. There are a lot of restriction. There are a lot of restriction with respect to size. The processes are not matured, so it calls for some of hybridization or optimization. Then people are not trained, says still it is not a process, not a subject taught in the engineering school in many schools, okay, except IITs and NITs. But otherwise, regular universities is still additive manufacturing is taught as just one chapter of a production engineering. And then these machines are not made in India, and they're expensive. There are a lot of challenges with respect to supply chain. So that is where we require Atmanirbhar in the capital goods and also on the material. This is just a story of additive manufacturing when you look at adopting this additive manufacturing as a industry production. So a little more details if you look at, yes, I wanted to use direct manufacturing, additive manufacturing for direct manufacturing. So one has to go through and solve these challenges at your shop floor. So still this technology is not solved by technology developer or technology OEMs. So therefore, the always technology scalability or adoption is need to be addressed at the early stage and every stage of research, technology, training, and applications. So we at CMTI basically addressing these kind of challenges in our selected domain. We basically undertake research, develop technology, machines, and then train manpower and deploy into industrial applications. So basically, we do to try to find technology interventions to address these challenges. Though these are our domains. You look at the machines and the pictures which I listed here, I won't take time. So each machine is industry ready. It is not a prototype. So when you want to have a technology, and these machines are still not made in India, it is made first time by CMTI. So when you are looking at that kind of technology, so that too industry ready. So definitely that calls for a different approach in the development cycle. I think many technologies scalability becomes challenge because we did not look at inclusive way. So this is just an impact. Say for example, a diamond turning machine which we transfer to Ace Designer, right? So this is
Hello,
Ace
sorry to
Designer.
interrupt you.
Yeah,
Sorry
this
to
is my
interrupt you, Mr. Naga. Can
yeah,
you
it is,
finish it within 2 minutes?
yeah, that's done. So this, if you look at the textile machine, this is again a technology transferred to 5 companies. The Indian company has commercialized, and we also do a lot of machines for a strategic sector, including some of the LRUs of aerospace. So what it means, our kind of learning from here is the technologies designed, developed, not necessarily the machines alone, including a process machinery, would cost you about 60% of imported cost. I think you believe yourself, develop the technology, I'm sure we will be able to make India as a manufacturing hub. But technology development also requires the integrated approach. Say, for example, if you want to build additive manufacturing machine, so one should have an expertise in a multiple domain like machine building, control, software, multi-material, laser processing. Laser because this is a laser-based AM. Then optical design, testing, standardization. I think all these domains are equally important, and all this domain expertise is should always focus on solving the challenges, as I mentioned, the 4P challenges. So this is a one success story which I wanted to put across. So if we believe ourselves and if we are open to work in collaboration, we, I or you alone cannot do anything. We together can do everything. I think this is one example. 10 institutes, including government and private, joined together to build a factory that is a metal casting foundry, which has a footprint of 16 feet by 8 feet and can produce 1 kg casting, and it is IIoT integrated metal casting foundry. This is possible only if we decided to do it. These all skill sets definitely available. It is available when you look at your neighbor as not as a competitor, you look at them as your enabler. I think that is what is grossly missing in our country. I think we need to focus on this. This is to summarize. Yes, there are a lot of challenges. I just made laser processing. If you take one technology, is applicable to every technology. So with respect to materials, subsystems, there are always limited options. And we have never looked at product, process, people, and production in an inclusive way. There are a lot of requirement is there to create a domestic IP. That is where we are a lot of the focus more on the customization or importing and customization or re-engineering or remanufactured is good. It will definitely immediately serve the purpose. But in the long run, if you really wanted a developed country in 2047, so definitely the domestic IP, domestic technology, I think that rules us. So we need to focus on that. So no shortcut. This is the golden rule. All technology development is an S-curve. Nothing is new, nothing is novel. The thing novel to me, it may be new to you. And let us build a building blocks. It doesn't no need to happen. It should happen overnight. So it's possible. You start from zero. Moving from zero to point one, point two is very tough. But once you move point two, moving to nine is kind of easy journey. Of course, if you want to be leader in the manufacturing, we need to create a domestic IP. So believe in our own HR, skill them and reskill them so that they will be available for us. That is only way to do is motivate yourself and then motivate others. So thank you very much.
Thank you, sir, for briefing us about the transformative power of 4 Ps in production innovation.